Hello my dears, how are you all? So in the last class we discussed about some important problems regarding the Masson'S gain formula. So let's continue some more problems and later on we will go to next topic. Okay. Okay, write a question. These are very high level questions. Okay. Question is find x9 by x1 minus. Find x9 by x1. You have to find the value of what? x9 by x1. That is the output by input you have to find. How can we start? See how complicated the figure is. Maybe this type of question may be asked now. Maybe not the fully, but a small portion like this may be asked. So you have to know the basic level. You have to know. See, my aim is we have to do maximum range of problem, right? Maximum range of problem you have to do. For examination, not up to that level may become, but a slight level may become, so that we can easily solve those problems. That is my aim. So listen my dears. So how can we start with? So what was our first step then? First of all, we have to calculate the forward path, right? First of all, we have to check how many forward paths are there. Then only we can apply the Masson'S gain formula. So how can I take P1? Listen. ABDLN. It's one of my forward path, right? So I can write like ABDLN. Am I right? A, B, D, L and N. It is one forward path. And another, my dear, ABFIMN, correct now? So P2 is equal to ABF ABC, ABFGLN. One more thing, we will start by this line, ABFGLN. And what is P3? ABFG already covered, ABFIMN. ABFIMN, am I correct, my dears? ABFIMN. So is there any on top side? No. Let's come to the bottom. So what is P4 now? P4 will be ACJMN. Am I correct? ACJMN. And what is another? ACHGLN. Am I correct, my dear? ACHGLN. Correct na? This is also a forward path na. Forward path means starting from the input to ending the output, and no repetitive nodes in between, that's all. So it will become ACHGLN. Correct? And is there any yes, of course. ACHIMN, correct na? ACHIMN. ACHJMN you already write na. ACJMN you already write. So ACHIMN, my dear, ACHIMN. Is it clear? So ACHIMN, ACHIMN. Okay, that's all. So we got what? How many? 6 forward paths are there. So corresponding there will be del 1, del 2, del 3, del 4, del 5 and del 6 will be there. So that all we have to calculate. Okay, my dear. So what is our next step? For finding the value of del, what we need? Loops we need, correct? Because del is equal to what? 1 minus individual loop gain. So we have to find how many loops are there, my dear. So let me first loop is what? See, DE is one of my loop now. DE is one of my loop. So I can write like DE, and in bottom also see JK is another loop now. So L2 I can write like JK, another loop. Is there any another loop, my dear? Yes. See, HIK, one loop now. I start from here, HIK. Similarly, see, my dear, start from here, FGE. FGE. HIK and FGE. Is there any another loop? No. No. Is there any another loop? No. So actually the question, if you find the Masson'S gain formula for this question, it will be very big question. So for simplicity, this, how to calculate only. Change the question to find the sum of loops and forward paths. Just alter this question like that. Or we want to calculate the full P1 del 1 plus P2 del 2 plus P3 del T divided by P1 plus divided by del. That much bigger will be the question. So you can do that. So change the question to find the sum of loops and forward path bus. Because now finding the forward path and finding the loops is the main issue here. Main issue here. If you know this, definitely you will go for the Masson's gain flow easily. Masson's gain formula easy. P1 del 1 plus P2 del 2 plus P3 del T, etc. you can find. Okay, can we do? We will do. No issue. We will do that. We will take it as a challenge and we will do. Okay. Don't change x1 by x1. Okay, my dear. Okay. So, what is then? What is del 1? Del first. What is del first? Del is nothing but, my dear. Del is nothing but 1 minus individual loop gain. Individual loop gain means L1 plus L2 plus L3 plus L4. Am I correct? L4 plus sum of product of two non-touching loops, my dear. Two non-touching loop means this loop and this loop is non-touching. Am I correct? Am I correct? Only there are 4 loops, my dear. So I can say that L1 and L4 are non-touching. Correct now? DE and L1 and L2 is non-touching. Correct now? So I can write like L1, L2. Is there any non-touching loop here? No. And I can say that yes, this and this is non-touching, and L1 and this one is the HIK. L1 and L3 also non-touching now. L1 is just this loop and this is the another loop. This is the another loop. Am I correct? So L1 as well as this bigger loop, that is HIK. Correct? HIK is also non-touching loop, right? So L1 and L3 also non-touching, plus L1, L3 plus. Is there any another non-touching? Let's see that. See, my dear. So these and these are non-touching. These are non-touching, of course. These are non-touching. There is no common. And my dear, this and this bigger is also non-touching. Correct? That means JK means L2 and JK means L2 and this bigger FGE means L4 also non-touching. L4 also non-touching. Is it clear? So this is bus. Is there any 3 non-touching loop, my dear? No, of course not, because there is only 4 loops are there. So of course there will not be any 3 non-touching loops. This and this already touching. So there will not be any combination of what? 3 non-touching loops, of course. So that's all. So this is called our del. Then what will be del 1, my dears? Del 1 is nothing but it is equivalent to del, but except what? The loops which are touching the first forward path. So what is our first forward path? ABDLN. So ABDLN means, so how many loops connected in ABDLN? ABDLN. So this and this bigger loop will touch, right? So I can say that DE and FGE means L1 and L4 are touching. Correct? L1 and L4 are touching on the first forward path. So I can definitely L1 and L4 I have to cut. So L1 cut means this will go, L4 cut means this will go and this will go. L1 cut means simply 1 minus, L1 cut means L2 plus L3 only. L4 also cut na, FG is also cut na. So 1 minus of L2 plus L3 only will be the del 1. Then similarly, what is del 2, my dears? What is del 2? Del 2 is also equal to, it is exactly equal to del, correct? Except the loops which is touching in the second forward path. What is the second forward path? ABFGLN. ABFGLN. So ABFGLN means it touches both these 2 loops. So I can again ABFGLN na. So it again touching the bigger loop na. So only these 2 will live. All other loop will cancel, correct? ABFGLN means it is touching this loop, means this and this will be cancelled, and here means this bigger loop also, this bigger loop also get cancelled. So only JK will remain. JK means L2 will remain, remaining all will goes out. So it will become only L2 will be there. So 1 minus L2 plus the remaining all will be gone, means everything is gone. So 1 minus L2 only. 1 minus L2 only. Then what is del 3, my dears? Del 3 is equal to what? loops which are touching the P3, ABFIMN, ABFIMN. So ABFIMN, my dears. So this gone, FIN, these also gone. I came here, FIM, M means this also gone. Everything will be gone. So it is simply 1. And what is del 4, my dears? What is del 4? So del 4 means Del 4 means ACJMN. Consider ACJMN. So this one go, only ACJMN. Okay, this one bigger and will go. Only these two will remain, that is D and FGD remain. G, D and FG. So but L1 and L4 remain, right? L1 and L4 remain. So L1 and L4 remain, but remaining all will cancel. L1 and L4 remain. L1 and L4 remain. L1 and L4 remain. So L1 L3 will be cancelled now. So L1 and L4 remain. L1 and L4 remain. So L2 also cancel. So it is only like this. So what will be del phi? What will be del phi, my dears? What will be del phi? Del phi ACHGLN. What? ACHGLN, correct. This means during this flow, cutting this loop, touching this loop, cutting this loop, cutting this, everything, every loop is cut by. So it is simply 1. And what is del 6 finally? ACHIMN. So during this movement, it is cutting this loop, it is cutting this bigger loop also. Correct now? Only this loop will be, D will be there, so the L1 only remain. So 1 minus L1 plus L1 only remain. That's L1, L2 is vanished, everything is vanished. So 1 minus L1 only. Okay, so these are the dels up to del 6 you found. See, it's very interesting, my dears, but you have to carefully observe, that's all. It's very, very interesting, but you have to carefully observe. Okay? Okay? Is there any doubt? See, finding it is there is a task. How can we find it? And of course, del will be, del you already found out. So what will be x9 by x1? x9 by x1 will be equal to p1 del 1 plus p2 del 2 plus p3 del 3 plus p4 del 4 plus p5 del 5 plus p6 del 6 whole divided by del box. That's all. Is it clear? That's all. You simply substitute and you will get. Okay. Is it clear, my dears? Can I run? Okay. Write another problem. Find C by R. Find C by R. See, this type of question, most what chances are there? More chances are there for asking this type of question, because the figure is very simple and the answer is also 2-3 steps. But you have to think a while in order to answer. You have to use your what knowledge level in order to answer this type of questions. Okay, how can we start with? We have to find the C by R ratio, correct? C means as an output and R means as an input. Is it possible to find C by R here directly? Is it possible to find C by R here? No. We can't find C by R directly because R is not strictly an input node. So I already mentioned you, but for the input node there will be always, or there is only outgoing branches, then only it can be considered as an input node. If there is any incoming branch there, we can't consider as the input node. And in bracket I mentioned strictly follows. It strictly follows. In the case of an output node, it is need not to be strictly followed that it should contain all the incoming branches. But in the case of an input node, please listen or please carefully observe one thing. It should contain only the only the outgoing nodes. No incoming nodes will be there. So R is again, see, there is a self loop of gain A here. There is a self loop of gain A here. So we can't consider A as the input, R as the input node. So how can we solve this? So for that, modify the figure as R, C, this is A, this is B, and this is 1, my dear. Okay, this is 1. Consider a dummy node like this. Consider a dummy node like this, and its gain will be unity. Let that be what? R dash, or simply R1. Consider a dummy node R1 which having a magnitude, that means from R1 to R it's having a unity, 1. And find that is C by R will be equal to C by R1 divided by R by R1, correct now? C by R is actually equivalent to C by R1, that is both the numerator and denominator divided by R1. There is no change, right? That is no change. So now this R1 is act as an input node because it contains only outgoing branch. This R1 is also this output by input now, my dear. Output by input means what? R by R1. For this, listen, this is output and this is input. Input is R1 here. Is it satisfying the input condition? Yes, it contains only outgoing branches. Okay, it satisfies. Consider the denominator. This is output and this is input. This is output and this is input. Focus on input only. Input is contains only R1. So it is again satisfying the input node condition because it contains only the outgoing branches. So no problem there. So find C by R1 and R by R1. That's all. So let's do that. Let's do that, my dears. So first C by R1. Let's find that. So C by R1 means, my dear, C by R1 means from here to here. Here to here. So I already told you loops and del is common for the entire system, correct na? Entire system loops and what flow, loops and del will be common. So what is P1 though? P1 here means 1, 1, 1. It's only 1, correct na? P1 is its first forward path. It is only 1, correct? It is only 1 na? Okay, it's only 1, correct? And is there any P2, my dears? Is there any P2? No, it is only 1 forward path here, all other loop. So P1 means correspondingly del 1 also be there, correct na? Del 1 also be there, correct? So for finding del 1 we have to know del. Before that we have to know loops. So let's find loops. L1 is equal to what? A, and L2 is also another loop, it is nothing but B. So there are only 2 loops, my dear, A and B. There are only 2 loops, A and B. So what will be? What will be del 1? Del 1, before we have to find del. Del is nothing but 1 minus individually loop again, that is A plus B, plus sum of product of two non-touching loop. Now there are two non-touching loop. It obeys two non-touching. This A is one loop, B is another loop, so they are non-touching. So plus AB. So 1 minus of A plus B plus AB. 1 minus of A plus B plus AB. Okay? Is it correct? Then what will be del 1, my dear? Del 1 is nothing but same as del, excluding the loops which are touching the first forward path. This is the first forward path, both of the loops are touching. So we have to eliminate A and B. Clear? So everything will be eliminated now. So del 1 is only 1. Del 1 is only 1. Okay? Is it clear? So what will be my C by R1? So C by R1 will be equal to P1 del 1 divided by del. So it will be P1 is part 1 divided by del. Let it be there. Let it be there. Okay, 1 by del. Next, what is R by R1? R by R1 we have to find. Okay, R by R1. So for R by R1, my dear, L is same, del is also same now. L is same, del is also same. Only del 1, P1 will be changes. Let's see. For that, what will be P1? C by R1 now, my dear. Sorry, R by R1. R by R1 means from the here to here only. So there is only one forward path. R to R1, there is only one forward path. Its magnitude will be 1 again. Its gain will be 1 again. And what is L1? L1 means, sorry, L1 and L2, everything is common. Na? So you can use this L1 and L2. P1 will be there. And what is del 1 now? Del 1 means nothing, my dear. During this movement from this R1 to R, this region, only this length, under this length, what are the loops which is touching and up to this length? So only A will be touching now. So you have to eliminate only A from what? Del. So it will become 1 minus of only A. So minus B, 1 minus B. You have to eliminate A means A into 0 into B will become again 0. So 1 minus B. Again. So what will be our R by R1, my dears? P1 delta 1 divided by del, which is equal to 1 into 1 minus B. Delta 1 is 1 minus B now, divided by del. So you know why I simply leave my left to my what del there without substituting directly, because there is use, right? So now C by R you have to find. Now C by R will be equal to C by R1 divided by R by R1, which is nothing but, my dear, 1 by del into del divided by 1 minus B. Simply 1 divided by 1 minus B. 1 divided by 1 minus B. How beautifully we arrived at the answer. How beautifully we arrived at the answer. My dears, the concept is very, very important. The concept is very, very, if you know the concept, you can play. You can play with the concept. So if you really don't know, you are stuck way somewhere, no? You are not at all that much confident in theory. It's very difficult. So as for our electrical inspectorate exam, I mean syllabus, it is for 10 mark, control system is for 10 mark. So it's very important. Okay, don't lose or don't skip. Control system is very, I know it's very difficult, but you have to study. If you study this, it's very easy. Revise it for at least 5 to 6 times before examination. Then everything will be in your mind. Everything will be in your mind. Rust it. Rust, it's in God's hand now. We can't do anything. Next heading. Block diagram to signal flow graph conversion. block diagram to signal flow graph conversion. Listen my dears. Consider a small block diagram first. So in order to convert it to signal flow graph, because from this block diagram, if someone want to ask you C by R ratio, then if this symbol means you can directly find from block diagram itself. But it is very big, suppose the block diagram is very big, means the best way to find the transfer function or C by R ratio is that you have to convert that block diagram into signal flow graph, my dears. Signal flow graph is actually a super tool in order to find the transfer function. So how can we find the signal flow graph? For that, this is considered as one node. So this is 1. The summing point is considered as another node. So this 2. This is considered, this is a looping point, and this is looping point and this is another. So the looping point is considered as another point. The output is considered as another point. I will again saying the input is considered as one point, the summing point is considered as another point, the looping point, so it is a takeoff point, correct? It is a takeoff point, so it is have certain importance. So that also considered as one point, and the output is considered as another point. Okay, join it, and from you can give any value or without value also you can do. See, from this summing point, this is R, this is R and this is C. From the summing point, this is summing point to this point the gain is G, summing point to this point the gain is G, and this point to again the summing point there is a feedback, and that feedback is nice. I can represent like minus H because this is given to the inverting terminal, right? The summing point negative terminal is given, so it is considered as minus H because it is given to minus terminal. So when consider the loop, you can consider it as a minus H. Okay, minus H, and that is all about the signal flow graph. So this is the block diagram and this is corresponding signal flow graph. This is corresponding signal flow graph. Is it clear? Is it clear, my dears? Okay, so this is the block diagram and corresponding signal flow graph. Okay, and now you can find the C by R ratio. Now you find the C by R ratio. Let's check that. Okay, C by R ratio you have to find from the signal flow graph. How can we find? For that you have to know the P1, correct? Number of forward path you should know, right? So this is the only one forward path, right? So each having magnitude 1, 1, 1, 1. So it will be forward path magnitude will be only G now. So 1 into G into 1 it will be G, simply G. Only P1 will be there, correct? Only P1 will be there. And what are the loops here, my dears? What are the loops here? It is only minus GS1 loop is there, right? Minus GS1 loop is there, no another loop. And what is del now? 1 minus individual loop gain, so minus GH. There is no non-touch loop also, so 1 plus GH. So that is the del, correct? And what is del 1? Del 1 is same as del except the loops touching on the first forward path you have to eliminate. So GH is the loop touching the first forward path. So it will be simply 1. Simply 1. So what will be C by R? P1 del 1 divided by del. It's only 1 now. So P1 del 1 divided by del. So it is simply G divided by P1 del 1 divided by del 1 plus H. Is the same now. Is it the same I derived first? In the first class I derived the expression, correct? By considering the error signal, by considering the R of S, E of S, B of S, H of S, G of S, C of S, everything I considered. I derived a long derivation and I found. See, in how simple steps we arrived at the answer. That is the power of what? Signal flow graph. That is the power of signal flow. But the problem where we fail is that considering the nodes. Sometimes we miss this node, sometimes we miss, if you miss any single node, the answer will be wrong. The answer will be wrong. So is that same now? G of S divided by 1 plus G of S into H of S you got now, the transfer function? The same you arrived here also. The same you arrived here also. Is it clear? Is it clear, my dears? Can we do another? Can we do another? Listen. Draw another question. Okay. Yes. Draw this. Draw this. So find C by R. Again the question is find C by R or C of S by R of S, no issues, or C of S by R of S. Find C by R or C of S by R of S. How can we do this, my dears? So first we have to convert this into signal flow graph. How can we do that? How can we do that? Listen, this is one node, correct? This is another node, correct? This is one node, correct? Sorry, this G1 is not considered yours. This is another node, correct? This is one node, correct? This is again one node, correct? This is because it's all take away point, na? The summing point is another node, correct? This is one node, correct? And the output is also one node, correct? So these much nodes are there. 1, 2, 4, 6 and 8 nodes. Am I correct? 2, 4, 6 and 8 nodes are there. And this is R and this is C. Okay. And see, my dears. So let's start from where we can start. So this is one. Okay. This easy is start from here. This 2, 1, 2. From 2 to 3, 4, 5, 6. So 2 to 6 you have to move. 2 to 6. Or from here you can easily convert like 1, 2, 3. From 2 to here 3. 2 to here 3. Having the value of minus h2. Okay. Everything you can connect, okay, no issues there. Everything you can connect. And this is nothing but my dears, G1. And again in between, that means 1, 2, 3, 4. 1, 2, 3, 4 and this is G2. Correct na? Correct na? 1, 2, 3, 4 and G2. Yes, correct. And from before that G2 means this is correct. G2 to summing point means this is correct. So G2 to summing point, there will be G3. So it is plus G3. So you can directly like plus G3. Okay, fine, very good. Next. H1 is from what, where to where? H1 is from here to here, where, my dears? 1, 2, 3, 4. 1, 2, 3, 4. So here is H1. So this is minus H1 I can write because see H1 is going to negative terminal, so it is minus H1. Is there any? No. Is there any? No. Correct? Second and third H1 and H2. H2 and H1 are second and third H2 and H1, correct? And G2 is from there to there G2 and G2. Okay. So remaining everything you put it as 1. That's all. So clear? So our diagram will be reduced to this finally. Can run this. So we have to find C by R ratio from here. That means if the question is from in block diagram, don't worry, convert it into signal flow graph and find the C by R ratio, that's all. Find the C by R ratio, that's all. So what will be the number of loops there? P1 will be equal to, forward path will be equal to the single one big line, right? This is one forward path, G1, G2, my dears. G1, G2. Is there any another forward path? Yes, of course. Here to here, here to here, here to here. Yes, is a jump and here to here. So it will be only G3. G3. Is there any another forward path now? Is there another forward path? No. Only P1, P2 is there. So what is L1 here? Loop 1. What is loop 1, my dears? This is not the loop, correct? How many loops are there? Yes, of course. This bigger will be a loop now. This bigger will be a loop now. So minus H2. One loop. And what is another loop? See, this bigger will be another loop. Minus H1 is another loop, correct? Or is there any another loop, my dear? Is there any another loop? So G3, is there any another loop? Yes, I can draw a loop like this. See, from here to here I can move my journey, my dear. I can move my journey from here to here. Here G3 minus G3 H2, correct na? Minus G3 H2, correct? So L2 will be, sorry my dears, L2 will be H2 G2. I forgot to write the G now. And this is H1 G1. So H2 G2, H1 G1. This bigger loop, now this loop is G1 G2 my dear. G1 G2 H1. G1 G2 correct. So G1 G2 H1 and G2 H2 and G3 H2 correct. All are the loops now. So now that's all. Is there any another loop? Is there any another loop here? No. Only these three loops are there. So how can we find del now? 1 minus individual loop again. L1 plus L2 plus L3 minus 2 non-touching loop. Is there any 2 non-touching loop my dear? Is there any 2 non-touching loop? H2 G2 and G3 H2. H2 G2. Yes, everything is touching now. Everything is touching my dear. So common non-touching loops are not there. Correct? Yes. And in between H2 G2 and H1 G1 G2 everything is touching. You can simply look from here. Is there any, if it is not any common term there in between, you can say that it is not touching. H2 G2 and here it is G2 is there, so G2 G2, and here come to here it is H2. So any two you can consider. You can consider these and two. So common is G2. Here and 2 common is H2. These and 2 common is again G2. So non-touching loops are here is no at first. No non-touching loop. That way also you can find. So 1 minus individual loop again is enough. So del 1 is equal to same as del excluding the loops which is touching on the first forward path my dear. So first forward path is my G1 G2. So G1 G2 if you means everything will be vanished, correct? So it's simply del. And that is del 2 now. Second forward path my dear. So this is my second forward path. Is there any loop which is not touching the second forward path? No. These two are connecting here, so it is touching. H2 and H1 everything connected to H1 it is connecting. So no. So it is simply del 1. So what is my C by R? P1 del 1 my dear. So G1 G2 P1 del 1 plus P2 del 2 my dear. So G3 into del 2 is 1 whole divided by del. Del is 1 minus of L1 plus L2 plus L3. So this is the final answer. This is the final answer. Is it clear? Is it clear my dears? Is there any doubt? You can ask. Is there any doubt? You can ask. Okay. It is very useful for those who are preparing university examination also, because in there also you can expect such a type of question and you can easily answer. Okay. And write another. The same format will be there, you can easily find, no issues there. Next. If it is electric circuit given, how can we find its signal flow graph? Let us do a somewhat difficult first, so that easy will be, you can answer very easily. Question is, find the signal flow graph of the given network. Draw the signal flow graph. Draw the signal flow graph. So this is a second order system, right? It's a second order system. I will later tell you what is an order and type of a system. I will tell you. So this is somewhat a familiar type of electrical circuit. So for that, for drawing signal flow graph, in the signal flow graph, did you notice one thing? It is contained G, G, H, like terms that are there, which means G means definitely open loop transfer function, so it have certain value. Transfer function, as the name itself indicate, it is in S domain. It is in Laplace transform. It is in Laplace transform. So now we have to convert this circuit diagram into Laplace equivalent. So what will be its Laplace equivalent? L of S. What will be its Laplace transform? How can we find it? So it will be Vi of S, correct? No? Va of t is Laplace transform Va of S. There is no change in R, my dear, so simply R1. And for capacitor it will be 1 by Cs, correct? And there is no R2 change, so R2 is same like that R2. Inductor will be changed like L into S. And the output will be changed like V0 of S. And there will be the currents, my dears. And we suppose this is I1 is given and this is I2 is given. So this will be changed like I1 of S and this is changed like I2 of S. And for drawing the signal flow graph, my dears, we need every point you need, which means you need here, you can consider as the input node. But this is also a node in electrical circuit. So same node will be there in the signal flow graph also. But what is the name of this node? This name can be given by the voltage across this node, which is nothing but simply Vc of S, correct? The voltage across the capacitor. And this is also another node, so that you can take the value of that node as simply what this voltage across this, which is nothing but V0 of S. V0 of S. So now you have, my dear, one node here, and that node you can mark it as Vi of S, no issues there. And another node, and the currents also you got, right? So now what is the step for finding the signal graph is that I will tell you. Okay, you just learn it and you just by heart in the sense you remember the order, or you just remember the order. See, I will draw here. So the signal flow graph will be, there will be one V1 of S. So V1 of S. Due to that, there will be an I1 of S. Due to that, there will be a Vc of S. And due to that, there will be I2 of S. And due to that, there will be V0 of S. So 1, 2, 3, 4, 5 nodes are there. So 1, 2, 3, 4, 5 nodes are there. Let's check how can we do this. Okay, how can we arrive the equation? See, my dear, V1 of S minus Vc of S by R1 will be I1 of S. Am I correct? What is the equivalent for I1 of S? I1 of S is nothing but Vi of S minus Vc of S divided by R1. Am I correct? So I1 of S can be formed by, my dear, V1 of S by R1. So into by R1, it is correct. V1 of S by R1, okay. Minus Vc of S by R1. Minus Vc of S by R1. So minus 1 by R1. So minus 1 by R1. See how I arrived? Okay. Similarly, what is I2 of S, my dears? I2 of S. What is I2 of S? I2 of S is nothing but the current through this, the current through this, correct? So I can write like it is V0 of S divided by Ls, correct na? V0 of S divided by Ls. Am I right? Vc of S, or I can say that this I2 of S is the current through this, the current through this R2 will be equal to Vc of s minus V0 of s divided by R2. Am I correct? Am I correct, my dear? Am I correct? So this I2 of s is equal to this voltage minus this voltage divided by R2, that only, that I will write. So how can my I2 of s formed? I2 of s will be equal to Vc of s. Correct? Vc of s. Okay, fine. Vc of s and minus V0s, Vc of s by R2 now, Vc of s by R2. So 1 by R2 you have to multiply, and minus V0 of s by R2, minus V0 of s divided by R2. So this I2 of s is formed by minus 1 by R2. So minus V0 of s by R2 is correct. Is correct. And what is V0s now? V0s now. V0s will be equal to, that is that I2 of s into Ls, correct na? I2 of s into Ls. I2 of s into Ls. So that, what is this I2? This is I2 of s into Ls. So Ls. So if you multiply I2 of s into Ls, you will get V0 of s. So multiply it with, correct? Multiply it with, you will get. So V0 of s will be equal to I2 of s into Ls. Okay. And what is Vi of s, my dear? Vi of s. What is this Vi of s? Vi of s is nothing but the input voltage na. So the input voltage can be write like how can I write the input voltage Vi of s? Vi of, okay. Consider this loop now. Consider this loop, my dear, this loop you consider. So I can write like Vi of s minus I1 of s into R1 minus 1 by Cs into I1 of s minus I2 of s equal to 0. Am I right, my dear? Consider this loop, just this loop. Vi of s minus I1 of s into R1 minus 1 by Cs into I1 of s minus I. Simple loop rule I applied there. So this is simply V1 of s is equal to I1 of s into R1 plus 1 by Cs into I1 of s minus I2 of s. So this is the Va of s. So apply here. So Va of s will be formed by I1 of s into R1. I1 of s into R1. Na? So correct na? I1 of s into R. The reverse will be I1 of s into R1. So I1 of s is V1 of s divided by R1. So V1 of s will be simply the reverse I1 of s into R1. So no need to reverse direction. See, already we learned what? This I1 of s is equal to V1 of s divided by R1. Na? So V1 of s will be equal to what? I1 of s into R1, correct na? I1 of s into R1. So no need to reverse direction, you can. No need. And 1 by Cs into I1 of s minus I2 of s, my dear. I1 of s, 1 by Cs into I1 of s, 1 by Cs into I1 of s. Okay, I1 of s, 1 by Cs into I1 of s. That you have to write, right? Yes. Another important thing I forgot, that is the output equation, the input equation, this input equation. You need not to be consider this into this signal flow diagram, because if you do these, all these, automatically this input is stabilized in this equation. The input, because we note one thing, we got I1 of s equal to what? V1 of s into R1. Na? It can be possible to draw this in reverse direction. It can be possible. No. In every parameter in the input equation, the same situation will happen. That means first you draw this I1 of s, that is like a B1 of s divided by R1. You draw, okay, you draw in forward direction. Then now for I1 of this V1 of S, what happened? This I1 of S into R1 will be happen. So it will be a loop like this into R1. So that is reverse process. So input equation, input node equation need not to be right. Need not to be right or consider. This is very important point. Or no input node equation. No input node equation. So now you got the signal flow graph for corresponding electrical network. Okay. So the trick to do this electrical circuit diagram is that first consider the input node. Due to that input, current will be flowing. Due to that current, there is a voltage drop, right? Due to that voltage drop, due to that current, there will be a voltage drop. Am I correct? So see the diagram V1 of S, due to that I1 of S, due to I1 of S, there is a VC of S, due to this VC of S, there is I2, because this current is the reason for flowing this current I2. Due to that I2, there will be a V0 of S, that's all. So make it that notes accordingly, and you can remember this order. This is very difficult actually, so it will not be asked in the examination directly because it's a lengthy derivation. It will not be asked. So anyhow you have to learn, that's why I told you. Is it clear, my dear? Can I have this? Okay. First order system next. First order system. Listen, my dear, before that, every LTA, linear time variant system, we are considering here linear time variant system, it having certain input x of t and it having certain output y of t. This y of t comprises of steady state value plus transient value. This output is always the sum of the steady state value yss plus the transient value ytr. What is this steady state and transient value? I will explain now. So transient means, my dears, if a sudden disturbance is happening in the system, then also the system will work and it will produce the output, right? So that the output due to that sudden disturbance in the system is called the transient response. Steady state means without any disturbance or without any external disturbance, the system works smoothly. So there will be an output produced, it is called the steady state output. So our primary, because considering the fault analysis or designing the circuit breaker for electrical circuit, designing the protection devices in the electrical circuit, we have to consider more about this transient response. And relating to the regulation and all, relating to the efficiency and all, we have to consider more about the steady state. That's all. We have to consider more about the steady state operation. And the steady state error will be equal to the there is an equation for this YSS, steady state value, which is nothing but, my dear, limit t tends to infinity y of t. Limit t tends to infinity y of t will be give you the value of steady state value. Steady state value. Okay. For example, right. For example, suppose y of t is equal to e raised to minus bt u of t. A e raised to minus bt into u of t. Then what is its steady state value? Steady state value is nothing but, my dear, I already told you, limit t tends to infinity into y of t will give you the steady state value. My dear, steady state means for long time it's existing. So for t tends to infinity also it is existing. That is the meaning of steady state now. So it will be nothing but applies limit t tends to infinity here, what happened? A e raised to minus infinity, which is nothing but 0. That means there is no steady state value for this function exist. Okay, so only transient response will be there for this function. So y of t will be only comprises of transient response. Just for information, I told you, it's not that much important. It's not that much important. Okay, consider another example. Consider another example, my dear. So y of t is equal to a into 1 minus e raised to minus bt into u of t. Okay, find the steady state and the transient responses. What is YSS now? What is the steady state response? Steady state response, I already told you, limit t tends to infinity into y of t. So which is nothing but what? A into 1 minus e raised to minus infinity u of t. Correct? T tends to infinity means, so simply you can u of t you can take it as 1 figure. For t greater than 0 means u of t value will be 1. So its value will be a into 1 minus 0, simply a. So there the steady state value exists. And what is the transient value? What is the transient value? From this the remaining term will be, from this you can explain like the transient value will subtract a from here, because a is corresponding to steady state value now. Subtract a from here, so minus a into e raised to minus bt will be the transient response. You just to subtract a from the y of t, that's all. Okay. Is it clear? Yes, sir. Poles and zeros of a transfer function. Poles and zeros of a transfer function. See, my dear, a transfer function is generally represented like so this is the general representation of a transfer function. So the numerator of the transfer function, that means I can write like poles. You can find poles by equating denominator to 0. That means if you substitute s plus p1 into s plus p2 etc. to s plus p1 equal to 0 and find the solution of that s, it will give you the value of what? Poles. And zeros equating the numerator to 0. For example, I will show you example. Suppose a transfer function is defined by s plus 3 into s plus 5 divided by 2 into s plus 8. What are the poles and zeros? What are the poles and zeros? So finding poles. What are the steps to finding poles? Denominator equal to 0. That is 2 into s plus 8 will be equal to 0, implies s is equal to what, my dear? Minus 8. So that is the pole. And zeros. Numerator equal to 0 means s plus 3 into s plus 5 equal to 0 implies s equal to minus 3, s equal to minus 5. So these are zeros. These are zeros. And how can you draw this pole and zero on your S domain? So our S domain consists of, my dear, S is nothing but sigma and j omega. S consists of sigma and j omega. J omega, or very specifically omega d. Or I can say that S is equal to sigma plus j omega, where sigma is called the attenuation constant and this is called the damping or oscillation. Not constant, it's simply attenuation, and this is j omega is nothing but damping or oscillation. This concept is very, very important. For your Laplace transform now, S is equal to what? What is the meaning of S? It is equal to sigma plus j omega. Sigma plus j omega. So, if you have this poles, right? See, poles is equal to what? S is equal to minus 8 is a pole means. Poles, S is equal to minus 8 means what? It is minus 8 is here. So, here is minus 8, a pole. So, sigma axis, there is a real axis now. This is a real pole now. So, sigma equal to minus 8 will be the pole. And 0 is equal to minus 3 and minus 5. So, that will be minus 3 here. 1. Minus 3, suppose minus 3, 1, 0. And so, this is minus 3 and this is minus 5. So, 2 zeros on the real axis. That is how you have to draw the poles and 0. Suppose you have another pole. S is equal to 2 plus 3j, you got a pole like this. S is equal to 2 plus 3j, you got a S equation like this. After solving, you got like this means, you got a pole like this means, what you infer from this? 2 plus 3j means, it contains both the real and imaginary axis. So, this is 2 and this is 3. So, 2 and 3 means, here will be that pole. Here will be that pole. It contains both the real and imaginary axis. That is the meaning of 2 plus 3j. Okay, we will learn, definitely we will learn more and more, we will learn. Okay, just for idea I told you. Okay, so that's all for today's session, my dears. And yes, one more thing I will show you. One more thing. After that we will wind up. Okay. Trick to find time constant. Trick to find time constant. See, consider an equation, my dear. So, what is the time constant of this exponential function? What is the time constant of this exponential function means? For find time constant or tau, what makes this equation as e raised to minus 1? What makes this equation as e raised to, what is the value of t which makes this equation as e raised to minus 1? That is the time constant for exponential function. So the time constant for this will be, so I will write for find tau, what makes the exponential function value as e raised to minus 1, or what value of t, what value of t makes the exponential function values e raised to minus 1. For what value of t it will make e raised to minus 1? T equal to 1 by a. So the time constant tau will be equal to 1 by a. That's all. And suppose you have 1 divided by s plus 3. As you have to find the time constant of this equation means, this is denominator now. So equating the denominator to 0 means you will get the value of poles. So it will be like in the -3 there will be a pole now. S is equal to -3, there will be a pole now. So this is sigma and this is j omega axis. So j omega d axis. So time constants here will be time constant here will be -1 by the next pole. This is the pole value. -1 by the pole value. -1 by the pole value. It is -3 now. -3. So it will be simply. So -1 by the pole value. I will write like -1 by pole value. Pole value you should consider the magnitude as well as this sign also you should consider. Don't consider this 3 only. -1 by 3 will be the answer. That is not the answer. -1 by -3. That is the 1 by 3 is the answer. Okay. And if you have this much poles you have, what will be? -3, -5 and -6. -3, -5 and -6. Okay. So what will be the time constant now means consider only the nearby pole of the imaginary axis. First nearby pole of the imaginary axis. So this is sigma and this is j omega d axis. So this is the imaginary axis. So consider only the first pole here. So the time constant will be -1 by the poles nearby. So it will be simply 1 by 3. Okay. So that is the trick to find the time constant. So it is useful. It's very useful during our program. Okay. So please listen and find it. So that's all for today's session, my dear. So let's meet again tomorrow with a new session. So until then, thank you. Bye. Take care.